Hi everyone, could you hear me? Yep, yes.
Yes.
Okay, and I think you can see my screen. Now we are going to learn about the VXLAN and campus network virtualization. And I want to ask if anyone have experience in DC network or the cloud network. And if you have experience in DC network, you should know that what is VXLAN. And I think if you have experience in campus network, you should know that in our traditional campus network, you should never meet the VXLAN technology, right? We will not use VXLAN in our campus network. But in this lesson, we will learn VXLAN just because in Huawei's solution, we have already introduced in last lesson. We call it the Huawei Campus Utilization Network. We will use the VXLAN technologies. And normally, in this solution, we don't need to deploy the VXLAN by manual. Just it means all the things can be deployed on the controller. You just need to click on the web page. But why we need to learn the fundamental of the VXLAN? Just because if you want to troubleshooting with the solution, I mean, if something was wrong, and if you want to know what this click mean, what this button means, and what have you done, and you should know what is VXLAN. And so after we click, we finish all the after we finish all the deployment on this controller, you will know what command have already been deployed on the real network device. You will find that we can finish all the deployment by the controller, and we have already a guide page. You can do everything, but if you don't know what VXLAN, you don't know what it means. So in this lesson, we will learn about what is VXLAN technology. Wait a moment. First. First, let's look at what is VXLAN. VXLAN, its full name is Virtual Extensible Local Area Network. You will find that it is only one word different compared to VLAN. It is extensible. So you shall know that it is just extended for the VLAN. And you can think it is one type of network virtualization over level 3. What it means, network virtualization, it means just to build virtual network over a level 3. So what it sounds like, it is like the level 3 VPN. Yes, it is. You can just think VXLAN is a type of the VPN. And you should know that every type of VPN have its own different packet frame. And what is the packet looks like for VXLAN? It is the mark in UDP. So what it means? It means we will encapsulate the original frame into a UDP header, and then we will cap the UDP header into order a new IP header. So what is the VXLAN packet looks like? I think it will look like that. It is a frame, orange frame, and then we will cap it into the UDP headers, and then it is the IP headers. So how to just meet the requirement of VPN? You can find that we have a new IP headers. So you can find that this is the frame carried by the older IP header. So you can think it is a traditional VPN. And usually, VXLAN has been widely used on data center network, but now campus network have increased the feasible server requirement and growth in virtualization network and network automation requirement. So Huawei introduced VXLAN into campus network, and of course, it is deployed by using the SDN controller. So now, in this lesson, we will introduce what is VXLAN. And we will know why we will introduce VXLAN this technologies for the data centers, and we will know what is the basic concept of VXLAN and the fundamental of VXLAN, and the most common application scenarios of VXLAN, and the most important and the most hard part to understand. It is the BGP EVPN. You will find it is a little difficulty if you didn't meet it before. Okay, the first part is the why we use the VXLAN and what is the campus network virtualization. First, let's look at the background of the VXLAN, why the VXLAN will be introduced. It is the virtualization. And now we should know that we will say now we are in the cloud age. All the service we will deploy on the cloud. Just maybe before we will deploy this service on the real service. For example, we will deploy the NGX, right? We deploy the NGX, MySQL, Apache, and other service. For example, other service, you know that, for example, PHP, we will use those with those things to deploy just a traditional, for example, the portal page of one complaints. But now we shall know that we can just easily finish this on the public cloud. And what is the new requirement that raised by all that introduced by the public cloud? It is the virtualization technologies. For example, we shall know that now in the public cloud, we don't have the real service. We have the virtual machines. And one requirement is the virtual machines, they need to communicate with each other, right? They need to communicate with each other. And what it means, we know that for the public cloud provider, maybe they have different data centers, and the data center are located in different cities, and maybe those cities are far away from another one, maybe in 100 kilometers or more than thousands of kilometers. So the physical distance is very long, but they need to communicate with each other and in layer 2. Maybe you will have questions why they must be in the same layer 2, just because you should know that all the virtual machines that you deployed on the public cloud, they can easily change from one data center to another data center, and you should know that before we change its location, the survey will not change. It means before they change the location, they have the same IP address. They have the same IP address. It means they have the same address, and then it will have a same gateway. So what it means? It means they need to in the same layer 2 network. So now it is a problem. Different the virtual machine in different data centers, they need to locate in the same layer 2 network. It means the broadcast domain will be very large in the traditional network. I mean, if we don't have a new technologies, if we only have the VLAN, the layer 2 network will be very huge, right? And another requirement is the isolation. We should know that in the public cloud provider, they survey so many customers, and for those customers, maybe they have the same subnet, just because you can design your subnet just by yourself. Maybe there are 2 customers, they just design the same subnet. So how to isolate them? Just you should know that if we put them in the same network, and they design the same subnet, it will wrong. It will be wrong just because the root will duplicate, right? So in our traditional network, we will use another technology. So we will call it WLF. That is one solution. But another problem is we should know for one tenant, we can say it is a layer 2 network, and for another tenant, it is another layer 2 network. How to isolate those different layer 2 networks? Maybe you will see we can use the WLAN technologies. That is right, but in the cloud public scenarios, it is not right, just because the number of tenants will be very huge. You should know that maybe it is maybe it is 100 millions, maybe. So we should know that the numbers of WLAN is not enough to isolate so many tenants. So we need to analyze technologies. First, these technologies can just action like WLAN. I mean, it can do the layer 2 isolation, right? Layer 2 isolation, right? And these technologies can make the layer 2 broadcast domain very huge. I mean, in the physical area, it can make a very large, very huge layer 2 broadcast domain. And then the number of the technologies, I mean, it can provide so many types of number for you to do the isolation. So what is this technology? It is the VXLAN. So now look at, let's review what is the challenge that facing by the traditional network. The first is the VM quantities. Nowadays, in our traditional networks, maybe just in our campus networks, we will also deploy the virtualization technologies. It means we will buy some service and we will just install the hypervisor on the service, and we can create a lot of VMs. So nowadays, the VM quantities have already be much huge than the real service. So what is the result? The result is the market adjustable size of level 2 device. Now it is increasing. And another thing is we have already introduced. It is we can know that the VLAN ID field, it is only the 12 bits. Maybe it's, now we have already seen it. In the data center scenarios, it is not enough to meet the requirement of the isolation for so many numbers of tenants. And then is the scope. It means the areas have already introduced. It's require the VM. It means the VM migration. It means one VM just migrate from one physical service to another physical service, and maybe the two physical services are located in different cities. And the requirement I've already said for sometimes is before and after migration, they must belong to the broadcast domain or the level 2 network. So how to make so a level 2 network that cover so much or so huge scope? That is problem. For VLAN, it means it is, you can do it, but you will find that is not reasonable, just because, for example, we have 2 data centers, and this VLAN is VLAN 10 for this VM, and it means you need to build a broadcast domain that can let the packet, the frame with VLAN Tiger 10 to pass through. You can make it, but it is not so reasonable. So what is the solution? The solution is the VXLAN. Now let's look at what is VXLAN. VXLAN, I have already mentioned it before. It is a VPN. So you can just think, and I have already said it. You can think it is a level 2 VPN, right? What it means? It means it carries the layer 2 network, layer 2 frame. So the first problem is scope. Is you will find that we have solved the first problem, the scope of the level 2 network. Just because now the layer 2 network is not a real level 2 network, it is a virtualization, it is virtualized network. So the scope can be very huge. And we have already seen it. VXLAN, it is a VPN that carried by the IP header. So it means, for example, it means for this switch and this switches, if they have the IP address and those IP address have the connectivities to each other, they can carry the VXLAN packet. It means for the VM migration, before and after migrations, they can belong to the same level 2 network just because they belong to a level 2 network that is virtualized. It is not a real level 2 network. So the first problem we have already solved just because we use the VPN technologies. And another problem is the number. So now let's look at how many numbers we can use in the VXLAN headers. Now we have now let's look at the VXLAN headers or the VXLAN packet format. We can find that we use the 24 bits for the VNR. What is VNR? You can just think it is something like the VLAN IDs. So you will find that now the numbers we can use have already increased a very huge and very large numbers, right? It is not as double. It is this, right? So we solve another problem, the number of the isolation. And then the last problem is the MAC address table size of layer 2 device. You find that for this device, we only need to maintain the MAC address of the VMs on the access device. But for the core switch or the aggregate switch, it don't need to maintain the MAC address table just because they are the only device for the VPN traffic. They just need to forward the IP header. So they just need to have the IP routing table, right? So the last problem is the number of the MAC address table. We have already solved it. So it shows that what is VXLAN? VXLAN is a VPN technology, and this VPN technology is a layer 2 VPN technology. It carries the layer 2 traffic. It means the frame, and so we call it. We say VXLAN will build or construct a layer 2 virtualized network, and we call it the overlay network. It means the overlay network is a level 2 networks. All the VM, all the service, the communication with each other by using the overlay network, and just corresponding to overlay network, we have the underlay network. It means it is a level 3 networks. So you find that for the level 3 networks, we can have a huge scope. Just because if you have the connectivities between each others, for example, maybe I'm in China and now maybe you are another country, just another side of the earth. If we have we have the IP connectivities with each others, we can build VXLAN tunnel. We can communication with each other in the level 2 network. So that is the VXLAN. Okay, so now let's look at what is the application of the VXLAN, but it is in DC scenarios, not in the campus scenarios. The first is VXLAN will be applied to DC network. It means the DC networks. And normally we will use the spine leaf physics architectures. It means we use the access switch to deploy the VXLAN technologies. It means those devices, they will deploy the VXLAN technologies. The traffic, the level 2 traffic will enter the VXLAN domain, or we can say VXLAN domain. Notice a new terminology. We call it the VXLAN domain. You can just think it is the overlay. Okay, all the traditional level 2 traffic will enter the VXLAN domain on the live on the live device. You can just think it is like the access switches. And for this device, it is a span device, right? And they only do the live 3 forward. So they don't need to support the VXLAN features. And you can find that for the physical architectures, you can find that it is a ECMP, right? It is a level 3 ECMP. It means, for example, for the device, you can call it the span 1. If it fails, right, we can use another link to another span. And if all those spans works normally, so we can forward the traffic from this leaf to this leaf. Just we can do a ECMP, right? So that is the most common physical architectures in the DC networks if we use the VXLAN. And what we say the apps layer serving networks, we just means all the overlay network is based on the networks and use the VXLAN technologies. And now maybe you will have the questions: how do we use the VXLAN technologies in our campus network? Actually, I think it is the same. Just the different things is now we don't have the tenant, right? For the public cloud provider, one tenant is one customer, and in campus network, one tenant is one maybe department. And now we also don't have the terminologies of the VMs. You should know that. So what is and we use the real terminals. You can just think it is a PC, right? It is a traditional PC's terminals, right? It is replaced of the VMs, but we use the technologies in campus network for the same aims. First, we can use the VXLAN technologies to do the isolation for different departments, and we can use the VXLAN technologies so that it means for one users, whatever we are, whatever, no matter which where he is located, they can use the same network just because we know that it is virtualized network. So you find that in this topologies, in this device, we have the video conference. It is a tenant. You can just think it is tenant. And for this place, we also have the video conference, and they can communication with each other just because they are in the same level 2 networks. So it means, for example, for the OA users, for the other users of other departments, no matter which access it is connected to, they can use the same IP address, right? So that is when we use the campus networks, just because whatever where I can use the same IP address to connect it to the network, and this network can do a perfect isolation for different departments. That is why we use the campus network, just because in campus network, we still need to, we can see we still have the requirement of building different network virtualization network. Okay, now let's look at why it is VXLAN technologies, but not the MPLS VPN or the VLANs. And the first, why we don't use the VLANs, I've already stated before, just because you should know that we have already said VLANs have so many disadvantages, just because if you want to build the large scope of level 2 networks, it is not reasonable. But VXLAN, you should know that you can build a huge level 2 network just by using the endless IP networks, right? The level 2, the network, the real broadcast domain will not be so huge. But why it is not MPLS VPNs? Just because you should know that if we use the MPLS VPN, we can perfectly meet the requirement of the isolations, but you need to deployment MPLS VPN technologies on every device of the campus, right? But you should know that for VXLAN, we only need to deploy VXLAN on the access device, right? For the core device or the aggregated device, they do not need to support the VXLAN, right? They don't need to support the VXLAN. Okay, now let's look at what is the VXLAN looks like. Let's look at the VXLAN packet format. The format looks like this, and I have already mentioned it before. So first, you should know that it is the encapsulated into the UDP headers and alter the UDP headers. It is the alter IP headers, so we can forward the VXLAN packet on the auxiliary networks, and in or after the VXLAN headers, it is the original data frame. And so what is the VXLAN header looks like? Actually, it just looks like this. You will find that it is a little bit like the VLAN, just because the most important part for the VXLAN header is the VNR. What is it means? The VNR, it means the which network identify. Which network identify ID, which network identifies, and it is like the VLAN IDs. You can use the VNI to distinguish different, or to different level 2 or different broadcast domains, or you can just use it to mark, to tell the receiver which VLAN or which broadcast domain of the original data frame is belongs to. Now let's look at some terminologies or the basic concept of the VXLAN. The first thing is the NVE. So what is NVE? It is the network virtualization edge. So you should know that what is NVE. Which NVE is just the device which is deployed with the VXLAN technologies. So you can call it the NVEs. And NVEs run VXLAN and construct a level 2 which network over a level 3 networks. You can just find in these figures, switch 1 and switch 2, they are the NVEs. And another concept is the V-type. Maybe you will be confused. What is the difference between V-type and NVEs? And you can just find that V-type is located on an NVE and encapsulate and decapsulate VXLAN packets. So you can just think that NVE is the device and V-type is the specific modules that do the real function of VXLAN. And in the alter IP header of VXLAN packets, the source IP address is the IP address of the source V-type, and the destination IP address is the IP address of the destination V-type. So you can find that we know that this switch 1 is NVE, switch 2 is NVEs, and inside switch 1 and switch 2, so we have the NVE module, and this NVE module have source IP address is the 1.1.1, and for the V-type modules inside this NVEs, its source IP address is the 2.2.2.2. And if they communication with each other, you can find that the alter IP headers is like that. Now let's look at another concept, VNR and SPD. So what is VNR? I have already said it is just a mark like the VLAN IDs. It is similar to VLAN IDs, and it is used to differentiate VXLAN segment. It means different broadcast domains. VMs in different VXLAN segment cannot communicate with each other at level 2. It just looks like your communication with the PC in other VLANs. If you want to do this, you need to deployment another technology. So for example, so you need to deploy the VLAN IFT, right? So it means VMs in different VXLAN segment communication with each other at level 2, but they can communication at level 3. Just you need to do some deployment to meet this requirement. And Another concept is the bridge domains. So what is bridge domains? VLANs are used to divide broadcast domains on a traditional network. Similar, BDs are used to divide broadcast domains on a VXLAN network. A BD defines a level 2 network broadcast domain on VXLAN network. So you find that what is the relationship between VNI and BD? VNIs are mapped to BDs in 1-to-1 mode. Terminals in the same BDs can communicate with each other of level 2s. But I think I need to emphasize maybe this word in the same BD will confuse you. Just look like the topologies. You will find that in these topologies, in switch 1 and switch 2, we all have the BD20s. It means broad domain. It means broad domain, bridge domain 20s. And you will find that we mapped the same VNIs, so they can communicate with each other just because you can know that between the device, VNI is like the VLAN ID. It is identifies. And what is the BD? BD is just terminologies on the device itself. It means now BD20 and BD20 on switch 1 and switch 2, they have the same VNIs, so they can communicate with each other. Just because if original data frame, right, that received by switch 1 in the BD20, right, and we already know that we have already bind a VNI values in with the BD20s, and we will kept the original data frame into the VXLAN headers, and this VXLAN headers will have the VNI number 2000, and this packet will send to switch 2s by the on-delay networks, and switch 2 receive it, and it will decapsulate the packets, and it will see the VNIs, and it finds that in its local configurations, VNI 2000 is bound to BD20. So you find that switch 1 and switch 2 just process the packet by itself. So it means what it means. It means, for example, now maybe in switch 1, we can create BD10 and we bind VNI 2000 in with BD2. So what is the result? Result is switch 1 and switch 2. They can also communicate with each other. PC1 and PC2, they are still in the same broadcast domain. So you find that the VNI, you can just think the VNI is a global terminology, but the BD is just a local terminology. Its work areas is just the device itself, but the VNI its working areas is the whole VXLAN domain. So I think you can understand it if you have a deep understanding about what is VLAN. You can it is not difficult for you. And then next is VAP. What is VAP? VAP is virtual access point. Now we have a question. In this topology, we have already said the original data frame we received by switch 1 and how switch 1 receive those packet. Why the switch 1 receive this packet? It knows it should belongs to BD10 or BD20. That is the problem. So that is the function of VP. VP, you can just think it is a virtual access point, or just is a logical, you can just a way to map the traditional traffic to the BD. And in campus network, why I emphasize the in-campus network? Just because in the data center networks and in the campus network, the device is defined. You know that in our campus network, the switch, we call it the S series, right? But for the data centers, the switch is the CE series. This support different way of VPs. But now we only introduced two types that as series support. The first one is layer 2 sub interface. So what is the layer 2 sub interface? For example, a layer 2 sub interface will create on device, and you will bind a BD to the layer 2 interface. That is the first way. Another way is we can bind the VLAN IDs with the BD. So that is the different ways of bind traditional traffic to the BD. But you will find that whatever, no matter which ways you use, what is the real things that WP does? You will find that the real things WP does is map the VLAN ID to VNI, right? Just because we see that in traditional network, right, VLAN ID is the unique mark, of this traffic. It will mark which broadcast domain this traffic belongs to, and what is the unique mark in VXLAN domain? We call it is VXLAN. So we will see that we need to just convert the unique identifiers that from the traditional network to the VXLAN network. So that is the function of WAP. And now let's look at what is the another concept. It is not about the technologies. It is just a habit. What is the border and what is the edge? What is edge? Which edge is a access device on VXLAN network? It means through which device traffic will from traditional network and the VXLAN networks. You will find that with edge is just looks like the VType and NVE, all right? And another device is the border. So what is the border? Edge is that traffic from the traditional network and the VXLAN networks. But notice that what type of traditional network? It is subnet. It is another level 3 network. Nope, it is not. So what is the traditional network? It means the terminals. It means the service. It means the access layer in the traditional network. All right, I think you know what it means. But what is the border means? It means the traffic just leave the VXLAN domains and go to the external networks. And actually, it is another. You can just think it is the real. It is the level 3 networks in traditional networks. Okay, so the traffic and the VXLAN domains and they can communication with each other. All right, but if the PC, the terminal, want to go to the external network, for example, the internet, how it does, right? So now we need to need the help of the border. This device, border, you can just find its name, right? Border is the boundary. Right? It is a boundary. It's a boundary. It is a boundary between the VXLAN networks and the traditional external level 3 networks. So how to achieve this? Actually, is you just do route import. You just import the router that designated to the external network into the VXLAN networks. Maybe now you heard this, you will be confused. VXLAN is the terminology about the level 2 networks, but why it has, you can import the router into VXLAN domains. All right, maybe you will be confused, right? Yeah. And we will introduce it in our in later page. Okay, now let's look at the last concept about the VXLAN, level 2 and level 3 VXLAN gateways. And level 2 gateways, it is just like the edge. So you can just like what is the definition about the level 2 network gateways? Forward traffic to a VXLAN network, or is used for intra-subnet communication on the same VXLAN networks. So what is level 2 gateway? You have already know it. It just means the device let the traffic enter the VXLAN domain. That is the level 2 network gateways. And what is the level 3 gateways. Just try to imagine, in our traditional networks, we have the VLANs, right? We use VLAN to divide the traffic into different broadcast domains, and how to let that how to let terminals that located in different VLANs can communication with each others. With the technologies we use the VLAN if technologies, and it is the level 3 gateways. All right. So the thing is the same. We divide the traffic in the VXLAN, right? How the terminals located in different VXLAN segment can communicate with each others. They need the help of the gateways, and this gateways is level 3 gateways. And so what is the level 3 gateways? It means the device that function or you configured the VBDIF. So what is VBDIF? It is something like VLAN if, right? VLAN if is the gateway of the VLAN. VBDIF is gateway of the BD. So that is level 3 gateways. Now let's look at the VBDIF interface. So I have already mentioned it before. So VLAN if interface are used for communication between broadcast domains on traditional networks. Similarly, VBDIF interface are used for communication between BDs on VXLAN networks. A VBDIF interface is a level 3 logical interface created for a BD on a level 3 VXLAN gateways. IP address can be configured for BDIF interface to implement communication between different VXLAN segments and between VXLAN and non-VXLAN networks, and to connected level 2 and level 3 networks. So you will find what is most important here. You find that a non-VXLAN networks. So what is a non-VXLAN networks? It means the external networks. It means the network that connected to external network, right? It means the network that are connected to the border, all right? And now you should know that why inside the VXLAN domains we can see that we can import routers, just because if you have a level 3 interface, it means that you have the routing tables, all right? So you have the routing tables, so it means the VXLAN actually it has the function of level 3. Now, at last, let's look at what is centralized gateways and what is the distributed gateways. For example, in this topology, we have 3 PC, PC1, PC2, and PC3. You will find that for PC1 and PC3, they are in the same subnet, and PC2, it is in another subnet. If we deployed the gateway in one device, it means the gateway of the PC1 and PC3 and the gateway for the PC2, they are located on the same device. Which device? On this device, we will call it the centralized gateway. So what is the distributed gateways? It means for PC1 and PC3, right? Yes, okay, you can go. All the recordings will be uploaded after our trainings, and I think someone will send the emails for you, and just don't worry about it. After our training, maybe it is the whole training finished, you can receive the emails and you can learn it by yourself. Okay, now let's continue. Now, for the PC1 and PC3, they are in the same subnet, and which place is the level 3 gateways, and actually is this device and this device, they all can be gateways. It means for this device and for this device, they will have a same VBDIF. This VBDIF will have the same MAC address and IP address, and this VBDIF will function as the gateways. Maybe if you think these things, you will find something is not wrong, but you just know why it is not right. But we'll introduce it later. And for PC2, we can just create its gateway on this device. So that is the distributed gateways. It means all the devices can function as the gateways. It means if you have a lot of the BDs, maybe in every type will create its level 3 gateways, and all the gateways will have the same IP address and MAC address. Maybe you will find that it will raise a conflict of IP address. All right, just like in traditional network, but it will not. But why it will not, I will introduce that later. Now let's drill into the important part. What is the fundamental of the VXLAN? So the first is the VXLAN tunnel establishment mode. We have already said before, VXLAN is a tunnel, it is a VPN. So for the VPN, how do we build the VPNs? We have two ways to build the VPNs. And we have already said it is a level 2 VPN that carried by the level 3 networks, right? Level 3 IPs. So it means if you want to build a VXLAN tunnels, you need to have a source IP address and a destination IP address for the VPN, all right? For the auto headers. So how to establish the VXLAN tunnels? We have two ways. The first way is static tunnels. It's just like the GRE. All right, it is just like the GRE. So you need to configure the local IP address and the remote IP address. And what is more important, it is WinIS. It means now we have two devices and we need to build a VXLAN tunnels into those devices. And which VXLAN segment traffic can pass through the VXLAN tunnels, right? All right, it's just like you configure a trunk port, you configure a trunk you configure a trunk channel between two switches. All right, you need to change the port type from access to trunk. All right, and then you need to specify which VLAN can pass through this trunk port, right? So for the VXLAN tunnel, it is a logical port. It is logical channel between two switches, and to let the level 2 traffic can pass through. So obviously you need to specify which traffic can pass through. All right, so you need to configure the WinIS for the tunnels. And another thing is the replication list. So what it is, you will be confused. I will introduce that in the next page, or it should be in next pages. Okay. Another way is the dynamic tunnels. So what is the dynamic tunnels? Dynamic, maybe I will introduce it in detail in the next when we're talking about it. But now we can just have a brief look. What is the dynamic tunnels? They can establish it by using BGP EVPN. One BGP EVPN is used to dynamically establish a VXLAN tunnels. The local and remote would have the first establish a BGP peer relationship before they exchange BGP routers to learn the WinIS and would have an address from each other. You'll find that after reading it, you still don't know what is the dynamic tunnels. It doesn't matter. Okay, now let's first look at what is static tunnels. Okay. We should know that static tunnels is not a stateful tunnels. For example, so we should know that IPsec VPN tunnels, it is stateful tunnels, right? Before we establish the tunnels, we need to exchange some packets, and we need to negotiate some parameters, and at last, we will have some parameters that you keep one copy in you by yourselves, and I keep one copy by myself, and by using these parameters, we can communicate with each others. That is stateful tunnels. It means we need to change some things, and at least for maintenance the channels, we need to use some parameters, right? That is stateful. But it's not. VXLAN is not. It is like GRE. So what is not a stateful tunnels? It means before we communicate with RGS, we don't need to exchange any parameters. We don't need to maintain any parameters, right? That is not stateful. And VXLAN is like GRE, right? They don't have a stateful, it is not a stateful tunnels. The address in the egress replication list is the tunnel destination address that is in absolute one VXLAN packet isolated and transmit over the VXLAN tunnels. So now let's look at the command lines. Okay, how to configure the VXLAN. Now we find that this is a WeType device. We use this command interface NVE to build one WeType, and we configure the WeType's source address. It means the source address of the VXLAN tunnel. It means the source address of the VPN's exception solutions. And then we have already mentioned it before. Which packet, which VXLAN segment can pass through the VXLAN tunnel? We need to specify it. All right. So we need to configure the NVR values. And for this NVRI, which is now we have the source. Now we have the destinations. So head and PI list, this command is used to configure the destinations. So now we have the source. All right, now we have the source. Now we have the source. We have the destinations. We have the VNIs. With those three parameters, we can build a VXLAN tunnel between two devices. All right. That is the static VXLAN tunnels. And this command and all those addresses followed by head and PI list, we call it ingress replication list. Why we call it this name? Maybe you'll be confused. Wait a moment, I will check if I have already mentioned before. Okay, doesn't matter. Let's look at. Okay, now let's look at in this page. Why we call it replication list. All right. Now let's look at these scenarios. BAM traffic forwarding. So what is BAM? It means broadcast unknown and unicast. And those traffic have the same characteristics. What is it? It means for a switch, if it receives this type of packet frame, it needs to do a forwarding, right? It means, for example, PC1 send a BAM traffic to WeType 1, and WeType 1 receive it, and it needed to do a forwarding. Forwarding to which destinations? It needed to forwarding. For example, all right. For example, in this WeType, we configured NVE1, we configured source address 1.1.1, and we configured NVI 200, and then it is the head and PI list. And the list is the 2.2.2 and 3.3.3. So that is the PI list, all right. And which part the traffic will be flowed to WeType 2 and WeType 3. But you should know that actually it is not the real flood, just because it is on the VPN, right? And this traffic is not flowed to. It is right. It is copies, right? The WeType 1 copied two traffic, one sent to WeType 3 and one sent to WeType 2. And what is copy? Copy is the replication, right? And so we will call the PI list. It is the replication list. So you should know that why we call it the ingress replication list. It is just because if we receive the BAM traffic and this device will copy the traffic and send it to the address in the replication list. So you can know that why we call it the replication list. All right. Okay, now let's look at how the forwarding entries looks like in the VXLAN scenarios. Maybe we can just see it on the real device. All right, you will find that it's not hard. It is just looks like the traditional forwarding entries of the traffic. We A moment, I need to see it. I don't know if we can see it on this device. Wait a moment. The MAC address. I don't know which video domain I have. Okay. Oh no, it is not like this. Oh yes, it is. Okay, now let's look like what is the 40 entries looks like. Actually, is for the switch, the 40 entries is still the MAC address, but the MAC address is not association with WLAN. It is associating with the bridge domains. So you find that it still have the output interface, or you should call it which interface it is learned from, and the type is dynamic. So, for example, so in this topology, so we have two PCs, PC1 and PC2. The PC1 is bounded to BD10, and PC2 is bounded to PT20s. And for BD10 and BD20, they have the corresponding WinRs. So you find that in the switches, the MAC address entries will look like that. You can just think, besides this part, it don't have any different that compared to the traditional MAC address entry, right? And now let's think another questions. How the switch forwards traffic to another WLAN type? I mean, if PC1 want to communication with this PC3 with this address, and the PC3 is in another switches. Okay, maybe it is switch 2. And then what the MAC address entries will look like, right? Okay. Now, let's look at how do they communication with each others if they are not in the same WLAN types. First, before we're talking about how they communication, let's look at why they can communication, right? It means we need to see the control plane, how the control plane works. And the control plane is still the forwarding and learnings. It is the same. So what is forwarding and learnings? Let's look at it. First thing is the PC1 want to communicate with the PC2. The first thing is it will send ARP traffic. The ARP is the bump traffic, right? And for switch 1 receive this packet, first it will record the source address of the ARP packet, right? The packet is received from the port 1, and it is bound to BD10, and now it will broadcast, right? Broadcast in the local BD. If there is another port also is bound to BD10, right? But now you should find that we don't have. So it will check its replication list, right? Increase the replication list. It will find that it has a V type. It has a pair list. The pair list is 2.2.2, and with the WinR values, and right, this WinR values is bound to BD10, right? So it will know that, okay, I can float or I can set the copy to this place. All right. And for switch 2, it receives the packet and it will decapsulate the packet, and it will check the WinR values. It finds that the WinR values is 1000, and it will find which BD have the corresponding values, right? It will find that in its local configurations, BD10 is binding with the WinR 1000. So it will, and the first things after it checks the mapping tables, okay, it is what it is record the source address, MAC address that PC1 sent, and learn form is not a physical port. Learn form is a address of the source address of the packet. So for switch 2, the MAC address entries will look like this. You will find that the learn form will be different. All right. And then what will happen is that, and then it will be switch 2 will do the forwarding actions, right? It will forward the packet, and the forwarding packet will received by PC2, and then PC2 will, wait a moment, and then PC2 will receive this forwarding packet, and PC2 then will send a unicast ARP reply, all right? And the unicast ARP reply will be received and switch 2, and switch 2 will form market address entries, and it is learned in BD time, and it's learned from with port 1, and then now it is for switch 2, right? All right, it will send the unicast ARP reply packets just because now it have this market entries, so it can do a unicast forwarding, and it keep the ARP packet inside the WEX tunnels, and then the switch 1 will receive it. After receive it, the switch 1 will do the same actions, just like what I mentioned in last page, what switch 2 will do. And it will form a new MAC address entries, and the MAC address is about the PC2, and it is learned from switch 2, all right? And then it do the unicast forward, it sends the ARP replies to PC1. After this control plan actions, now switch 1 and switch 2 have the market entries about PC1 and PC2. They both have, and PC1 and PC2 have the market entry ARP entries to each others. Then PC1 and PC2 can communication with each others. That is how they communicate with each other. You will find that if you're thinking the WEX tunnel is the trunk port, and if you think BD is VLAN, you will just find that the things is not different. The things is all you known before, just different terminologies. All right, the working mechanism is still the same. Forwarding and flooding and learning is still exist. All right, and it doesn't changes. The things is the same. And now I think you have already know what is the next. The next is inter-subnet forwarding of unicast packet with known destination address. Switch 1, switch 2 have the MAC address, and PC1 and PC2 have the IP address, so they can communication with each other. So how to communicate with each other? I think you know that. I don't need to explain them, right? All right, and now it is the bump traffic forwardings. I have already sent it before. So it's just it will copy packet and send it to the IP address in the replication list, and then they will receive it. Just looks like this device. It looks like it have already do the flooding actions, but it is just a action of simulation of forwarding. It is not a real forwarding. And then it is the inter-subnet forwarding. So things will be a little different. Now we shall know that if we want to do a forwarding between inter-subnet, we need to use the gateways, and inside WEX is the gateways is the VBDF. You will find that for the VBDF, we will configure its IP address. And now for PC1 and PC2, the gateways is located on the switch 3. So what it means? It means between switch 3 and switch 1, and between switch 3 and switch 2, now they both have the WXLAN tunnels, and these WXLAN tunnels is used to carry WXLAN packet with WinR ID 1000, and this is used to carry the packet with the WXLAN ID 2000. Okay, now you just think, now for this is a bridge domain, and for this part, it is another broadcast domain. All right, broadcast domain, different broadcast domains. So the first thing is the PC1 will want to do inter-subnet forwardings. So the first thing is it will require the ARP of its gateways. Okay, it will do ARP, and the process will be the same, just like we introduced in this two page. Okay, after this, PC1 and gateway will learn each other's IP address, and for switch 1 and switch 3, it will have each other's MAC address entries. So first, the IP the IP packet that sent from PC1 and descended to to server2. All right, it will be received by switch 1 and then switch 1. And now you should know that the Ethernet header, I mean the outer Ethernet header, so okay, it's the destination. No, I mean the original data frame. No, I'm sorry, it is wrong. Now for the original data frame, switch 1 receive it, and its destination MAC address will be this, right? It is this data frame is sent to VBD10, and then the switch 3, so VBD10 will receive this packet, will receive these data frames, and then it do the decap solutions, and it finds that the destination MAC address is itself, and switch 3 will know that, oh, this traffic is sent to me, and I need to do the level 3 table forwarding, table looking, and then send it. So what is the result? The result is switch 3 will check the destination IP address of the IP headers, and it will find that, oh, I should forward this IP packet just according to this root address. You'll find that it is a direct root address. And then after we find the root address, and then we need to find the IP address and the MAC address, and then the packet will send from switch 3 to switch 2, and switch 2 will forward it to server 2. So that is the data frame forwarding about the basic concept of the VXLAN. You will find that if we're talking about the basic concept of VXLAN, if you just can do some imaginations about its relationship between the traditional VLAN, you will find that it is not difficulties. All right. Now let's look at the configuration about the VXLAN configurations. The first is how to create a VLAN. VLAN, it is a BD. It is like a VLAN. This command is a BD domain. We can create a BD in a system view and enter the BD view. And then it is create a WinI. Inside the BD view, we can create a WinI with the WinI values. And then we need to configure a NVE interface. We shall know that if we want to real configure the VType function, we need to create an NVE interface. And for the NVE or the VType module, we shall know that we need the source address, we need the destination address, and we need the WinR values. So the first command is configure the source address of the NVE interface. And then we need to configure the ingress replication list, configure WinR and the hand-end peer list. And then is how to do the VEP, how to configure the VEP. Okay, the first is we configure encapsulation mode. We can by a server interface. For example, now you can find that it is a server interface. Wait a moment. Oh no, we don't have this. You will find that it is a server interface. It should be a level 2 server interface, and then we need to configure its capsolution.eq VID. All right, and then inside it we need to bind BD to it. All right, we need to bind BD to the level 2 interface. And also we can bind a VLAN to a BD. It means we can use the VLAN view. We can use this command, level 2 binding VLAN. We can use this command to configure the mapping relationship between VLAN and BD. And at last, how do we configure a level 3 gateway for the BD? It is easy. we use interface VBD if, just like the process we create VBD VLAN if. Now let's look at two configuration examples about intra-subnet communications. The first one is we have IP123. We have three PCs, and they are in the same subnet, and we need to deploy the intra-subnet communication between switch 1 and switch 2. So how do we configure it? We just need to configure switch VXLAN tunnel between switch 1 and switch 2, and they are in the same WinR. So the first thing is we need to do the NVAP. Oh, right. How do I do it? No. The first thing is we need to configure the bridge domain. The things it should be the same on the switch 1 and the switch 2. We need to create the VBD, the bridge domain 100, and then we need to configure a corresponding WinR values to it, right? And the value should be the same. And then we need to configure the V type. Yeah, right. We use this command, interface NVE. Interface NVE. Use this command to configure the source address and the replication list and the WinR values of the NVE. And then the last thing is we need to configure the VAP. All right. On the switch 1, we use the first way to configure the VAP. We use the level 2 subnet interface. All right. You can see this command. Interface gigabit Ethernet. All right. And we set the subnet interface is mode to level 2. And inside the interface, we bind it to a bridge domain. But for switch 2, we just demonstrate another way of the that how to bind the BD and the VLANs. You will find that inside the bridge domains. All right, inside the bridge domains, we use the level 2 binding VLAN. We just to do this to bind the VLAN to the bridge domains. And you should know that inside the bridge domains we have a unique WinR values. So just by use this, we just mapping VLAN to bridge domain, and then we map bridge domain to WinR values so that VLAN IDs can be mapped to WinR values. And then it is the centralized, by using the centralized gateway to meet the requirement of the inter-subnet communication. You will find that switch 3 will function as the centralized gateway. It means we will create VBD for two VBD on switch 3, and for switch 1 and switch 2, they just do the function of the V type. All right. So let's look at the configuration. The first one is on switch 1 and switch 2, we need to create the bridge domain. We need to do the mapping between WinR and bridge domain, and then we need to configure the V type. And you will find that for switch 1 and switch 2, the V type configuration is different. They need to configure the different WinR values. And then we need to do finish the VP configurations. For switch 1 and switch 2, we use the same way. We use the level 2 sub interface to finish the VP configuration. And at last, on the switch 3, we still need to configure the bridge domain. All right, and we need to configure the V type, but we do need to configure the VAP. All right, but on switch 3, we need to configure VBD just by use the VBD if PC1 and PC3, this PC, PC1 and PC2 can communication with each other. All right. Now we can have a rest for 10 minutes, and then we will learn new concept. It is a BGP EVPNs, and it is. And actually, I think about this type, we mainly talking about what is BGP EVPN type 2 routers. Okay, and if you have already learned what is MPLS VPN and what is the BGP EVPN type 5 routers, and you will find it is not so difficult for you to understand it. Okay, we just take a rest for 10 minutes. Okay, now let's continue, and I think you can see my screen, all right? Now, let's enter the third part about this lessons. It is the BGP UVPN. And maybe first let's talking about why we need to use the BGP UVPN. The first problem is the tunnel numbers. If we use the static way to build the western tunnels by ourselves, so what is the problem? The problem is with the increased numbers of way types, and the western tunnels numbers will increase. And if we create it by ourselves, it is will be the configurations will be heavy, and maybe it will last a lot of time themselves. And another problem is the flooding and the learning mechanism is used to learn MAC address, right? As a result, a large amount of traffic will be flooded. It's just because if we don't use the BGP UVPN and we use the manual static western tunnels, and it is will be the result. And if we use the BGP UVPN as a control plan, what we can do is BGP UVPN, we should know that we can to use BGP UVPN peer relationship. All right, we use this, and what we can do, we can use the BGP routers to complete VXLAN control plan operations. What it means? It means we can use BGP routers to exchange the information that we need to establish the western tunnel peers. So what information? Maybe it will include the WIN numbers and its source IP address. And okay, western tunnels will automatically establish through BGP UVPNs, and forwarding entries and dynamically updated through BGP UVPNs. So you will find that by using BGP UVPN, we can establish the western tunnel automatically, and also we can finish the MAC address learning by itself. Now let's look at what is BGP UVPN. And you should already know that by the previous learning, you know that BGP UVPN, it is the extended for BGP, all right, and we use another attributors. It is MP rich NLRs, all right, and we define some new NLRs, and those new NLRs can carry those information. So for example, they can carry the table 2 routers, and we can see that what is included in table 2 routers. It includes the MAC address, it includes the IP address. So you can find that with these routers, we can deliver the AIP info and the host router and the MAC address. All right, we can use the routers. So it means maybe we don't need to use the floating and learning mechanisms. We can finish the MAC address learning. And also we have the type 3 routers. We call it the inclusive multicast routers. We can use these routers to transmit level 2 VPN. You don't need to care about what is the level 2 VNS. You just think it is VNS and we type address information. So you will find that when we introduce how to establish western tunnels, we see that we need the source address, we need to VNR values, we need IP address information that the destinations. So you will find that this router will carry the peer information to you. And if you think you can communication with it. For example, if you have the same level 2 VNRs, it just means you can establish western tunnels with it. So you don't need to configure it by yourself. And at last, it is the type 5 routers. You can find that its name is IP prefix routers. It is used to advise the host MAC address, IP address, IP routers, and external networks routers. And its most common use is used to carry the external network routers. You can just think IP prefix routers, just like the normal the BGP routers. It is IPPlex routers. You can use this to import router that designated for external routers to the VXLAN domains. So the VXLAN domain, I mean maybe the VXLAN level 3 gateways, the VXLAN level 3 gateways have the router to the external network. All right, now let's look at what is the UAP LR looks like, and you will find that maybe now when we learn BGP UAPN for the VXLAN scenarios, you can just compare it to the VPN V4 routers. I mean, they are similar in some place. Okay, now let's look at what is important for the VPN NLRs. First, you can find that it is carried in MP-rich NLRs, and its address families is level 2 VPNs, and its subsequent address families is the UVPNs. And inside the UVPN NLRs, we will find those things what will carried in the extended community. Those communities, we find that for the UVPN routers, it will carry some path attributors. These path attributors are extended communities. Also, you should know that for the VPN V4 routers, it will also carry the extended communities. All right, and what communities we will carry? The first thing is the RT values. So, what is RT values? Actually, the RT values is the same. Same meaning in compared to the RT values in the VPN V4. You use the RT values to control which one. I mean, in the VPN V4, you should know that you control it. You use the RT values to control which VPN instance can receive or can learn the route. All right, and these RT values in UVPN, it is the same functions. And another function is the MAC mobilities and routers MAC extended communities. But for those two extended communities, we will introduce it when we're talking about it. Okay. First things, like let's talking about what is the UVPN VPN instance. You maybe, and I think we have already said it before when we talking it in the VPN instance experiment. Okay, now let's look at what is one moment, and I think IPv instance, and so what is the VPN instance? You find that it just things like this. It is like the traditional VPN instance. It has the RD values, it has the RT values, but it is bound to what? It is bound to the, you find that it is bound to the bridge domains. So what is the UVPN instance? UVPN instance, you will find that it is bound to a BDs. We shall know that MAC address entries of the BDs, okay, will be transmitted through the BGP routers. All right, it means for BGP UVPN, MAC address enter is a router, and the router will be carried by BGP UVPN. Also, we shall we see that the router ending. I mean, the BGP UVPN router, it will carry RT values, and these RT values will control which VPN instance can receive these routers. But now it is not the VPN instance; it is the UVPN VPN instance, and those instances are bound to the BD. So you will find that, for example, for switch 1 and switch 2, they have the same BDs. Actually, it doesn't matter if they are the different BDs. It is okay, and they bind VPN instance, UVPN instance, and those UVPN instance have the RT values. It has the export RT and the import RTs. So we have seen that before. MAC address will generate the BGP UVPN routers, and the routers will be delivered from switch 1 to switch 2, and switch 2 receives the EVPN routers. It will receive the routers depends on the RT value carried in it. It will look at itself's configurations to search which BD have already banned the VPN instance, and if the VPN instances import IDs are equal to the RT values, and then if it is equal, for the MAC address entries that carried by the EVPN routers will be put on the BD's MAC address entries. So that is the meaning of the EVPN instance. You can just imagine it is like the IP VPN instance, but now it is used for the MAC address entry. It is not used for IP address entries. So now let's look at what the routers looks like. Okay, we use this command BGP EVPN all routing table. It should have routing table entries. It is too much. MAC routers. Okay, let's look at what is looks like. You find that for this next hop is the 0.0. It means this route is generated by itself, and you will find that for these routers, what it looks like. You will find it look like this. You will find it look like this. You will find it look like this. Okay, you will find what it does represent. This it means the length of MAC address length. This it means the length of the IP address. You will find that this is used to carry the MAC address, and this is used to carry the IP address. So you find that for the EVPN routers, it can carry the MAC address, and also it can carry the IP address. And if you combine it together, it is the AIP entries. All right. And actually, this is the host router. All right. Now let's look at what the BGP EVPN routers looks like. For the BGP EVPN routers, we have 3 types. It is type 2, type 3, and type 5. The type 2 is used to carry what I have already said before. It is used to carry the MAC and IP address information. So how do it carry it? You find that what is the most important part for the type 2 routers? In the type 2 routers, you will find that it has the MAC address length, and actually you don't need to consider about it because it is a fixed value. So it will always be 28, and then it is followed by MAC address. It is used to carry the MAC address entries, and also it has the IP address length values. And you should know that you don't need to consider about it just because it's always be 32. Okay, and then it is used. It will carry the IP address, and then you find that we have 2 values, and its name in the format of MAC address routers. You find that it is the MPLS label 1 and MPLS label 2. All right, MPLS label 1 and MPLS label 2. Just imagine in the VPN v4, if we have 2 MPLS labels, what it is represent for respectively. You can just imagine that, right? For example, now we have VPN v4 routers, and wait a moment, and I don't know. I think we need to use another scenarios. Okay, just let's think. You can find that the description for the first description, it is level 2 WinRs. What is the level 2 WinRs? You can just imagine that all the WinRs that we're talking about before, it is a level 2 WinRs. It means it is used to specify which broadcast domain that is the VXLAN segment belongs to. So that is used to level 2. Just use to clarify which VXLAN segment, which VXLAN bridge domain the frame belongs to. Okay, that is its functions. But what is level 3 WinR? Maybe you'll be confused. What is level 3 WinR? Maybe now it is not easy for you to explain it, but you can just think it is the MPLS It is the MPLS label. Which label? MPLS label. It is a label that assigned by the BGP protocol for the private routers. Just thinking about the MPLS VPN. Just think about the MPLS VPN. We know that in the MPLS VPN we will have two level labels. The outer labels is assigned by the LDP protocols, and the inner label is assigned by the BGP protocols. All right, and what is the function of the inner labels? What is the function of the inner labels in the MPLS VPN scenarios? Maybe you will say, oh, it is used to specify which VPN instance it belongs to. All right, maybe you will say it is used to clarify which VPN instance this router belongs to, and then if you receive the MPLS the packet, and you will check the corresponding VPN instance routing tables by the MPLS label. All right, actually, the level 3 VPN have the similar function, just like the inner label in MPLS VPN. Okay, just remember its function is like that, but why I see it, I will explain it later. Now, just let's look at for the type 2 routers, we have different, in the different scenarios, the type 2 routers will carry different contents. First, if you use the type 2 routers just to advertise MAC address, so you will find that we will only carry MAC address length, MAC address, and the level 2 with NRS. So it means all those field is empty. Okay, and if you use it to advertise ARP entries, you will find that MAC address length, MAC address, IP address length, IP address, and MPLS label 1, label 2 winner will be used, but this will still be empty. And at last, if you use to do an IP route advertisement, all the field, this field will be used. But why? Why now we need to use the level 3 VPN? It should be the level 3 VPN. Why now we will use all the values? And what is the level 3 WinR is used for? Maybe you'll be confused. And why now we call it the IP router, but now it is IP router branches. Okay, now just let's look at different scenarios. You will find the result, find the answer. The first scenario is we used the BGP UAPN type 2 routers to implement dynamic MAC address learning. This function is used to implement intra-subnet communication. You should know that we use the MAC address. It means, for example, in the switch 1 and switch 2, all right, we see that we have the BD, and we see that inside the BD will configure corresponding the EUAPN VPN instance, all right, and inside the EUAPN VPN instance, we will configure the RT values, RD values, and the level 2 WinR values, all right. And for the switch 1, it receives, for example, if the PC1 send any traffic to switch 1, and then we have received it, it will form a MAC address entries. Inside this MAC address entries, we have the BD, we have the port, we have the MAC address entries, and then we'll form type 2 routers. And inside the routers, we will carry MAC address, we will carry MAC address length, we will carry RT values, we will carry WinR values. Of course, now you know it is level 2 WinRs, and we will carry the RT values. And switch to receive this BGP UAPN type 2 routers, it will check the RT value carried in it, and it will check is in itself, in this device itself, so which BD have the corresponding import RT values. It finds that it is in BD10, so it will receive the type 2 routers is in its BGP UAPN ranges, and then it will convert the BGP UAPN type 2 routers to the MAC address entries, and then it will install the MAC address entries in its MAC address tables. That is the MAC address advertisement. and then it is the AIP advertisement. The things is like the same, but the different things is the BGP Type 2 routers, BGP UPN Type 2 routers will carry different things. It will carry the AIP address in the same time, and the switch 1 will form this BGP UPN Type 2 routers by the AIP address. It means, so now you can imagine that now for the switch 1 and the switch 2, it should have the level 3 gateways, so it can form the AIP address, all right? You can form the AIP address, all right? And you can use this, for example, the switch 1 and the switch 2, and now it can learn the AIP address and also the MAC address address, right? And normally it is used in the centralized gateway scenarios. The inter-subnet packet forwarding process is similar to that in static scenarios. And last, it is the most difficult part. It is the inter-subnet communication in distributed gateways. First, just like the review how do we do the inter-subnet forwarding in VLAN through VLAN if interface. For example, for PC1 and PC2s, PC1 it find is the destination of address to the PC2. They are not in the same subnet, so it knows it need send traffic to its gateways. Its gateway is VLAN if 10, and by the AIP packet, it will send the gateway's MAC address. So between PC1 and VLAN if 10, we can see that the switch is do a level 2 forwarding. So we call it is bridge. All right, it means level 2 forwarding. And after the switch received the packet or the frame, it will decapsulate it and find its destination MAC address is VLAN if is a level 3 interface of itself. So it knows, oh, I need to do a routing. Yeah, all right. It means it is a level 3 route entry. It means this device needed to look for needed to search the level 3 route entries, and then, all right, it needed to do a bridging. All right, it finds that for these routers, the router is a direct router, and then it needed to do a intra subnet, right, between VLAN if 20 and PC2. It is a intra subnet, and then between and in this segment, it is still the bridging. So we find that between if we see the whole process that PC1 communication with PC2, you will find that we can divide it into 3 parts. The first one is bridge, and the second one is routing, and the last one is bridge. Okay, that is the inter-subnet forwarding in a VLAN scenarios. But if it is in the VBDIF, but if it is in the VBDIF scenarios and in the distributed gateways, what I mean, now in VType 1 and VType 2, we also have the VBDIF. We all know that between PC1 and its gateway, VBDIF, it is the bridging. It means VType 1 will search the level 2 address. It means it will search the MAC address address. And we all know that between VBDIF 10, between VBDIF 20 and between VBDIF 20 and PC2, it also is a bridging. All right, it means it is a level 2 for forwarding. But the problem is between VBDIF 10 and BDIF 20 is we know that it is a routing forwarding. But the problem is VType 1 have the VBDIF 10. VType 1 also have the VBDIF 20, but VType 2 also have the VBDIF 20. If PC1 wants to communication with PC2, we will finish the routing on the VType 1. Also, all right, on the VType 1 we can finish the routing process. All right, it means VBDIF 1 will check the will check the will search the root entries, and then it will find it is the direct routers, and then VBDF 20s will search the level 2 entries. It will find VBDF 20 will find that it is a multi-address entries, and then it will forward it to we have 2, and we have to receive it and find I need to do a level 2 forwardings and send it to PCA2. That is the first way. Another way is what? Another way is VBDF 10 can send this packet to VBDF 10 on WTAP2, and then between WTAP 2's VBDF 10 and VBDF 20, they can finish the routing process. That is the problem. How? For the first way, we can imagine it, but for the second way, how? How BDF 10 sends the packet to VBDF 10 that belongs to WTAP2? How? That is the problem, all right? So now let's look at the first way. The first way, it also, we can call it as the asymmetric RIB. Why we call it asymmetric RIBs? Just look at like the detail process. Okay, the first thing is the PC1 will send a unicast packet to PC2. The PC2, and then we shall know that this packet is destination MAC address is VBDF 10s, all right? And the VBDF 10s receive it, it knows, I need to search the routing tables and all right, I search it, and I need to, this should be, wait a moment. And this the WTAP1 search it and should know it. I need to send this packet to VBDF 10, and VBDF 10 will, okay, it is the direct router, and VBDF 10 will require the MAC address tables of the BD10 and finds that destination MAC address, all right, and you should know that this MAC address is linked by the type 2 routers, and so the packet between WTAP1 and WTAP2 will look like this. It means the source MAC address is the PC1's. No, it is not PC1's. The source MAC address should be the VBDF 10, and the destination MAC address should be MAC address B. All right, and the VNR values. Notice the VNR values should represent, should be specified to tell WTAP2 that the packet, that the frame is belongs to the BD 10. All right, so the WTAP2 receive this packet. First, it will check the VX header. All right, it checked the VX header, find it is the VNI 100. So it knows this packet should be processed inside bridge domain 10. So, and then it check its destination MAC address. Its destination MAC address is MAC B, not any, notice, not any MAC address of its level 3 interface. So it knows I need to do a level 2 forwarding, not the level 3 forwarding. So what WTAP2 will do? WTAP2 will send this packet to PC2 just because it will match a MAC address entries. So you will find that what? Find for the ingress device, ingress WTAP2, it finishes the level 2 and the level 3. It means it finishes the bridging and routing actions. But for the egress WTAP, it only does the bridging actions. They are not the same, so we call it asymmetric RIBs. RIB, it means integrity, routing, and bridging. So you find that egress and egress, they have the different action behavior. So we call it as asymmetric. All right, they have the different actions. So we call it asymmetric. So now we have another ways. The second ways. The second ways is the symmetric RIBs. So just let's back to this place. We said the second way is the ingress WTAP will send the packet to the egress WTAP and tell notice, and it needed to tell the egress wait type which we believe the packet belongs to. So the important thing is how the ingress wait type tell the egress wait type the packet belongs to which we believe. So just try to imagine these answers. You will find that it is like the Ampere sweeping, all right? It is like the Ampere sweeping. For the Ampere sweeping, the ingress PE needs to tell the egress PE which sweeping instance the packet belongs to, all right? Right. So the answer is what? The answer is we can use if we need if we wanted to do a symmetric RB, it means the second way. The second way, all right. The egress wait type, we need to send the packet to the egress wait type and let the egress wait type do the level 3 routing forwarding. So the egress wait type need to tell the egress wait type which we believe the packet belongs to. So how to tell it? We introduce another. No, I think it is not a new terminologies. It is just the traditional IP VRF, and this VRF needed to be bind to the VBDF. Not it is needed to be bind to the VBDF. So you can just try, just imagine how do you use the IPVRF in MPLS weaving scenarios, and what is the RT values in RPVRF is used for. You maybe you can just imagine that in the IPVP instance, we use the RT values to control if the packet can be received, the route can be received, and then if we received, and also along with RT values, we will use MPLS label, all right, to MPLS label. To use the MPLS label to specify which MPLS, which VP instance the packet belongs to. So after I received the packet that sent by the egress PEs, just by check the MPLS labels, I know which VP instance the packets belong to. So that is the same in the VXLAN scenarios, but just we call it the level 3 WinIS, and we bind the IP VRF into the VBD if 20s. And inside the IP VP instance, we still have the RT values, and we have another WinIS. You can just think it is MPLS values, and you can just think it is like the MPLS private labels. Okay, now we have another problem, new problems. We find that just like look at this page, we call it the IP route advertisement. Now we have already answered the first questions. What is the level 3 WinIS? You know that this level 3 WinIS is used to tell the egress the egress device which packet which VPN instance or which we believe the packet belongs to. But another problem is now we have two RT values. All right, we know that now we have BD, we have we believe, and inside BD and inside BD, inside we believe and inside we BD, we both bind VPN instance. But one is VPN IP VPN instance, but another one is EVPN VPN instance. But they all have the RT values. So which RT values will be carried? That is problem, all right? Now let's look at the answers. After an IP VPN instance is added, the RT values carried the type 2 transmitted by BPN is still, notice, is still the EVPN RT values, is the RT values will always be the RT values of the EVPN VPN instance. The only difference is that the remote and process the receive route differently. No, let's look at if the RT carried in the route is the same as the import RTs of the local UVP instance, the route is accepted after the UVP instance obtains RB routers. It can extract RB routers from the RB routers to imply advertisement. So you find that the UVP instance will check the we will do differentiate, and if we can accept the routers, we can extract ARP routers, and also we can extract MAC address entries. All right, from the routers. And if the RT values in the routers is same as the RT of the local UAP instance, the router is, and then the level 3 UAP instance obtains the IP address prefix routers carried in the routers extract the host IP address and the level 3 UAP address, and saves the host IP routers of the host 1 to the routing tables. So what it means? It means RT value only have one values, but we will try to compare these values with UAP instance and IP VP instance. And if it is equals, we can, if it equal with the UAP instance, so we can learn the MAC address and AIP entries that carried by routers. And if besides the RT values can also be equal to the import RT values with one level 3 VP instance, then the router entries will be learned by the VP instance. All right, so that is the different. We can just use one diagram to explain these things. You can find that for the weight type 1, it is the ingress weight type. Or just you can just say it is the weight type that send the router out, and we have the BD20. All right, BD20s, and we have the UVP import RT values, and for the BGP update messages and for the type 2 routers, we will carry the RT values, and notice that this RT values is the UAP RT values, and we will carry UAP routers. Maybe the UAP routers is RRB routers, all right? And then on the weight type 2, we received these routers. First, we will compare the RT values carried in the BGP update message, compare it to its locals RT values. All right, it find the values is equal to the import RT values of the BD20s. So the UPN routers will be received by UPN routing tables, and then notice that, and then it will try to extract maybe MAC address entries or the AIP entries to the corresponding entry tables, and then after that, it will try to check if the RT values can equal to any import RT values of any VP instance. Okay, it finds that it can be equal to the IP VP instance, and then it will put the host IP routers, it means the NRB routers, to the corresponding IP VP routing tables. And now I will try to show you by just try to show you by a real device. You can find that, for examples, BGP routing entry, BGP UAP routing tables, MAC routers. For examples, for these routers, you will find that it carried the MAC address, and it carried the IP address, and I need to do these things. I need to check the router its verbose information. You will find that it have RT values. All right, it have RT values, and this RT values is just one RT values, but you will find that wait a moment. But you will find that label info, you will find that it have two labels. You shall notice that this router is learned from another BGP European peers. It have two labels, and let's check it. It is on this device. Wait a moment. It should be, maybe it is learned from this device. Let me check it. BGP European routers display BGP European router routing tables all. MAC address routers. Oh, it is in this device. We can check it. You will find that, all right, and let's check it. We will find that this is in this subnet, all right, in this subnet, and maybe we can try to find which subnet it belongs to. We can just to maybe display AIP entries. You can find that for this, it is in this device, and it should be AIP entries. wait a moment, it is belongs to RD. And I display IP interface brief. And it should belongs to this VBD5. You can find that it belongs to this VB instead. Its gateway is this interface, and it have already bind VP instance RD, and you can find that inside the VP instance we call it RD. You can find that we have already configured Wexland WinR values. It is 9, and you find that in H2, this routers it has 2 labels. This is the 9. It means the level 3. Level 3 WinRs. It is MPLS level 2, and also we find that it is VBD5. It means in this device we have a BD domain. Its number is 5. BD domain 5. You can find that. All right. In BD domain 5, we have already bind UVPN VPN instance. We can check it. UVPN VPN instance UVPN 5, and it is should be BD mode. And it is in the BD mode. And you can find that in this it have also have a wait a moment, it showed in the bridge domain. Notice. You will find that in the bridge domain it also have a Wexland IDs. It is WinI 10s, all right? And you can check the RT values. For this UVPN VPN instance, its import RT values is this and this, right? And we see that for the BGP type routers, the RT values will always be the UVPN VPN instance RT values. So we find that for these routers, its RT values is what? You can find that it is those tools, all right? Those tools, all right, all right. And now let's check it on the BD, and let's check it on this. You can find that, for example, in bridge domain, maybe you can trace the check IP VPN instance. You can find that. Oh no. Maybe display the IP VPN instance OA. You can find that we have the. Now you can find that for the VPN instance, the OA it doesn't have the corresponding import RT values, but for the IP VPN instance RD, we have the corresponding import VPN target, right? It means the router address, which routers? It means this router address. We knew that for this router address, this router address it will carry the host routers, okay, and for the host routers carried by the type routers, it will be received by this VPN instance. So we can just check it, IP VPN instance RD. You can find that inside this VPN instance, we can find this router address, and it is IBGP router address, and its next hop is this, and its interface is Wexlands. And besides, in the bridge domain, we find that bridge domain 5. It has the corresponding import RT values. So you can find that in the market address entries bridge domain, you can find that we can find the corresponding. Wait a moment, you can just check it. You can just see its prefix about the market address. You can find that it is anyways EFEA. You can find that EFEA. You can find that. You can find that we have already learned it, and it is learned from vtype. So you can just find that just use one router. So we carried the IP routers, and we also carried the market address, and also we should also carry the ARP entries. You can find that if we carry the IP entries, No, I think we don't carry it just because we use another features. But no, it doesn't matter. Just because we use this these features. We use features ARP. Oh no, ARP. Wait a moment. ARP distributed gateway enables. We use these features so we can't see the ARP entries that are carried by the another way type. But now you should know that by using the IP VPN instance and the UP instance, we can just carry the IP. We can carry the root entries and the MAC address entries, and we can control which VPN instance can learn it just by use the RT values. So now let's look at the examples. What is the symmetric RBs? Now first it is the control plans. How do we do the root advertisement? First, we have the PC1, PC2. The PC2 will for example, the switch to have already ARP entries of PC2s, and it have already generated an ARP routers. All right, now for the switch 2, it will generate BGP update messages, and we will find that the EVPN RT values, it is the RT values inside the EVPN VPN instance. It shall be this. And for this entries, it will carry the host routers and the MAC address about the PC2, and also it will carry the level 2 VNRs and the level 3 VNRs, and then it will be received by switch 1. So I have already said switch 1 will lend the MAC entries to the corresponding MAC address tables and lend the root host to the corresponding IP VPN instance routing tables. So you find that it will lend the router, the host routers, and it is like that. It will have the corresponding level 3 VNRs, and you should know that this routers is inside the VRF. This routers is inside the VRF. All right. Now the switch 1 have the host routers to the PC2. All right, and it have the level 3 VNRs. It have the next hop. All right, and another RT values now I will introduce. It is the routers MAC extended community attribute. It is used to transmit V types router MAC address entries, which is the MAC address of the NV interface. Why we need to carry the V types MAC address? And you should know that this MAC address is represent the V type itself. For example, now we will have the root MAC. It is MAC B, and the MAC B is represent the switch 2 itself. Why we need to do this? Now let's look at the communication process. It is a forwarding plan. Now PC1 want to communication with PC2. First, it will send a unicast packet to PC2. The first is always a bridging. All right. The first is already all right. We have one will receive it, and it will check the destination MAC address, and it will find the destination MAC address. It should be the VBDF 20 itself, so it knows. Oh, I need to do a level 3 table looking. All right, and it will find the routing table, and you should know that on the type 1, VBDF, BD20 and BD10, you find that they are bounding in the same VPN instance. It means they have the same RT values, and they have the same level 3 VNR values. No, but it doesn't matter. We just know that it will check, it will search root entries in the routing table, and this routing table is the VPN instance routing tables, and it will find the result is the host routers. Just because we should know that we will the routing table when we search routing tables, we will do the longest match. All right, so it will match this root entries, and then for these entries, it has the corresponding level 3 VNR values. And now remember, V type 1 need to tell the V type 2. This router is sent to V type 2 to process, and V type 2 should to do level 3 forwarding. All right. level 3 forwardings. And now, I don't know if you remember why a device will do a level 3 forwardings. Just because the destination MAC must be one interface, one interface of itself's MAC address. So that is why we said we need to do a root MAC to represent the WTAP2 itself. Just because when we send the packet from the ingress to the egress, we need to do the egress. This packet is sent to you. You need to decapsulation it and do a level 3 table looking. And then we shall know that we have a VXLAN headers, all right? And this headers is specified which VP instance this packet belongs to. Okay, now the WTAP2 receives this packet, and the VNR values is 1000, and it will check, and then it will check the destination MAC address, and it will find the destination MAC address is the MAC address of itself. So it knows, oh, this packet I need to search the level 3 table, level 3 routing tables, and you should know that maybe for the WTAP2 it have a lot of VRFs, so it means it have a lot of routing tables. Which routing tables to looking for? So now it uses the level 3 VNR values to judge. So now it is the RRB, and then you find that WTAP2 now it receive it will do the routing process, all right, and then after it must find direct routers, just because for WTAP2 it is the gateway of the PCI2, so it must will find a direct routers, so it must will do a bridging process. So now you will find that egress WTAP will do routing and bridging, and for the egress it also will do a bridging and routings. So that is why we call it is a symmetric RRBs, just because egress and ingress and egress always do the same process. So you will find that you can just imagine the level 3 VNRs is MPLS private labels, it shall be MPLS private labels. This label is used to tell the egress device which VP instance this packet belongs to. And then we need to destination MAC address to set it to the root MAC, just because we need to tell the egress device, guys, this packet is sent to you. You need to process it itself by you, not search the level 2 tables. You should search the level 3 tables advance. Now we have already finished the type 2 routers and type 5 routers. Now we should have say what is type 3 and type 5 routers. We have already finished type 2. So what is type 3 routers? Type 3 routers is used on the VXLAN control planes for automatic type discovery and dynamic VXLAN tunnel establishment. Just imagine when I say we need to establish VXLAN tunnels, what we need is the source address or the address of UPS and the VNR values of UPS. Those informations, the VNR values is used to decide if you can establish VXLAN tunnels with it. Just because you also, if you have this VXLAN value, the VNR values, and UPS also have, it means you can establish VXLAN tunnel with it, and with which IP address that is carried in the tunnel identifiers or the IP address just because just because they are same values. So now let's look at how it works. It means switch 1 and switch 2 they will set after they establish the BGP EVPN peer relationships, and normally you will not establish peer relationship directly. They will use one RR. So it means it will receive the routers reflected by RRs, and these routers will carry the VNR values and VTAP address. So for example, for switch 1, it receives the routers that stand by switch 2. It will find, oh, you have the same VNRs with me, and your IP address is this. I will establish a VXLAN tunnels with you, NATI. And for switch 2, it is the same. So now let's look at look at what is the type 3 routers in real device. Let's look at it. Display BGP UAPN all routing table inclusive router. You can find that it is inclusive routers. For example, let's use these routers. Maybe it should be this. All right. You find that in these routers we will see the RT values, all right, and we will see the WinR values. Actually, it is the labels. You find we only have one labels. It means the WinR values. And you will find that we have the PMIS, and you will find that the tunnel identifiers. The tunnel identifiers is defined for we have the source address. So by using these routers, we can automatically establish a BGP UAP pairs with another device. And then let's look at what is the type 5 routers. Type 5 routers, you can just think it don't have any different with the VPN V4 routers. For the VPN V4 routers, we use the RT values to control which VPN instance can control it, and we use the label to mark it, to tell mark it. All right. So you can just think the level 3 WinR is the MPLS label, and the prefix is the VPN V4 routers. It is used. And you can find that, for example, for switch 1, it is a level 3 gateways, and it also have another interface. This interface may be just a normal IP interface, not the VBDIF, just a normal IP interface. And this interface is bind to the VPN instance. For example, the boards bind to the VPN instance. For example, for VPN-A. And actually, maybe they are not bound to the same VPN instance, just because maybe for example, this interface is bound to VPN-B, and we can set the RT values to light on switch 2. All right, the VPN-B is export RT values, and we set switch 2 the level 3 gateway binding to VPN instance VPN-A, and by control the RT values, we can light switch 2 then the external routers that connected to switch 1. All right, it's just like the normal MPLS VPN labels and then normal MPLS VPN V4 routers. It doesn't so difficulties. Let's just look at like it. For example, now in borders, for example, we have the border device. Okay, now let's look at it. In the border device, we can see it. We have the IPv4 instance service. Okay, the service IPv4 instance service. You can find that IPv4 service. You can find it's, for example, it's export RT values is this, export RT values is this, and you will find that it should be bind to interface maybe. Okay, you find that this VPN instance is just bind to a normal VLAN and check written table VPN instance service. You will find that we have so many routers, and it is static routers, and these routers have already imported from the survey to the RD and OA VPN instance. And now you can find that IPv4 instance, RD. You can find that its imported RT values have these values. So you can find that in its routing table with instance RD, you can find so many you can find this root address, and its next hop is learned from service. You can find that it's learned from service. That is how type 5 routers works, and you can find that on this device. BGP UAPN all routing table prefix route. You can find that it is so like it is very like it just looks like It just look like the weeping waveform routers. You can find that weeping instance RD. You can find that they are so likely. And then let's learn some features about the BGP UPNs, and it will be useful. The first one is the ARP broadcast splicing. It is now we know that with that BGP UPN type routers will enable web types to learn MAC address without depends on communication between hosts. However, ARP entries between hosts still need to be flooded and forwarded on the vexed overlays. So now we have known that we can just deliver the ARP entries by the type 2 routers. So if we can reduce broadcast and traffic, we can configure these functions and how it works. Let's look. For example, now we have already received the ARP the ARP request. So we have one. We will have the ARP entries about the PC1. So let's look at it. It is the ARP entries. It has the IP address, MAC address, and we have it itself IP address. And then now we know that, and then we shall know that. And no, I think we should look from another sequence. Just we shall know that we type 1 have already the type 2 routers about the PC2. You have find that we have already the type 2 routers, and now PC1 send an ARP request to PC2, and just by decap the packet and looks the ARP entries field, we will know that PC1 will know which IP address PC1 is required for, and then we have knows PC1 is required for PC2s, and it has PC2's MAC address and we have address. So what you can do is we have ones will change the destination MAC address of the ARP packet from OFs to MACB and send the ARP packet only to WTAP2. So now you will find that this packet, if we look at it from the level 2, it is the unicast frame, and if we look at it from the level 3, it is the unicast IP packet. So we can reduce the flooding. All right, that is the ARP broadcast splicing. And another function is the host information collection. When ARP broadcast splicing is enabled on a device, the device generates the ARP broadcast splicing tables. ARP broadcast splicing entries are originated from the type 2 routers, but by default, the level 3 gateway will not generate BGP UPN routers. I mean the type 2 routers based upon local ARP information. So you need to manually enable BGP UPN host information collections. So by the ARP entries, we can generate ARP routers based on ARP entries. So this is just the functions. You need to enable it. And let's look at it. We should enable it. Let's look at VBD if we can enable it on VBD 5. All right. And check it. It is have already enabled ARP collection host enabled. So the VBD will generate type 2 routers by the ARP entries. And another function is the local proxy ARPs. So what it means, after BGP UPN host information collected is enabled on the entire network, the level 3 gateways learns the host routers of all routers, all right? For example, the WTAP 1, it have the host routers about the PC2. So in this way, you find that level 3 gateways can use the symmetric NRB mode to forward traffic between hosts in the same BDs. So what it means, PC1 and PC2 in the same bridge domains, and WTAP 1 have the host routers to PC2. So now, why the WTAP 1 needed to do the level 2 forwarding? Just because you can find that the WTAP 1 can do a level 3 forwarding to the PC2. So in this case, you can enable local proxy ARP on the VBD interface of the level 3 gateways. The VBD interface responds to the ARP request packet sent by downstream host to an IP address on the same network segment. Then the level 3 gateway performs level 3 forwarding on the same network segment. Just because you can find that PC1 send ARP request to PC2, and on the VBDF20 we enable ARP proxy local enables, and then the PC1 will receive the ARP entries about the PC2, but the entries corresponding MAC address is MAC-C, and then we will find that, the PC1 send the packet to PC2, and the destination MAC address is PCC. PCC about the MAC address is MAC-C, and MAC-C receives this frame. It will check its destination MAC address, and it will find that it is to itself, and then it will search the routing tables, and it will find host routers. So, and then it will do a RB, symmetric RB forwarding to WTAP1, and WTAP2 will do a route and bridging process, and at last send it to PC2. So you will find that without these functions, actually, by use these features and by use BGP UAP in WTAP routers, we can just limited the broadcast domain in the switches, and between switches we don't have any broadcast bump traffic. All right, and then another function is distributed gateways. Okay, although now we have between the WTAPs, all the forwarding is the level 3 forwardings. So for the WTAP1 or the WTAP2, it is not necessary to maintain that the ARP address that is not belongs to itself. For example, for WTAP1, PC2, it doesn't for WTAP1, it don't have the necessary to maintain the ARP address about PC2, so it just delete it. So that is why you can find that for example, that is why in H1 or H2 you find that, for example, display ARP entries. You find that in the RD domains. You find that in the RD domains, you will find this ARP entries. All right, you will find the ARP entries. But in H2, normally it should can see the ARP entries, but you can't. Why? Just because we enable these functions. You can find that we don't have any ARP address about this. Normally we should learn that just because we have already enabled this function on the VBDF5. And you can find that VBDF5 is binding to VP instance RDs, and we have already enabled this function. ARP distributed gateway enables, so it will delete all the ARP address that not belongs to those terminals that is directly connected to itself. That is the distributed gateway. And another function is the MAC mobilities, and this function is used is most commonly used in the data center scenarios. So what it is the, let's look at, if now we have the VMs, this VMs is now connected to WTAP1s. WTAP1s learns the ARP entries of VM1, and then it will generate an advanced ARP routers, and WTAP2 will receive it, and this routers and this MAC mobility extended communities will carry the sequence numbers. And then if the VM1 moved to another WTAP, for example, is WTAP2, and it shows that VM1 will send traffic, and the level 3 gateways on the WTAP2 will be awareness or VM1 have already migrated to mine, and so it will realize it, and it will send WTAP2 will send another BGP European routers, and it will increase the sequence numbers to 1. So WTAP3 receive it, and it will find the sequence number is larger, so it will update the router. And also for whatever one, it will receive the routers, and you will find that the sequence numbers is also larger by the routers that sent by the cells just before. So whatever one will knows, I should withdraw the routers. That is the market mobilities. And at last, let's look at some terminologies or the concept about Huawei's solutions. Huawei call it the VXLAN-based virtualized campus networks. So what it does, it uses the VNs. Actually, the VN, it just the VRF. VN is VRF. VN can be created based on survey requirement to implement service isolations. VXLAN is used to implement level 2 and level 3 communications. Virtualization topology is used to construct a logical topology based on any physical topology, just because we can use the VRF technologies. All right. A server network is created in Fabric and decoupled from physical network, and you should know that just because it is VXLAN. Physical network established by physical device, interoperability for all services on the campus networks. Basic BRI network for service data forwardings, and you should know that we have the underlay, and we have overlays. Overlay is a Fabric device, and we can build different wings. It means we can create different VRF on the overlays. And now let's look at what is the architectures. In Huawei solutions, we define those nodes with terminologies. The first is firewalls. In some scenarios, we will use it just to protect the level 4 to level 3 securities. And then it is border nodes. Border nodes is the same meaning with the VXLAN terminologies. It just this device to external network. And then we have the agent node. Agent node it also have the same scenario, same meanings with just like we introduced before. And what is the transport node? Just you can imagine it is like the span node. It just do the level 3 forwardings, and it do not to need to support the VXLAN. That is the transparent node. And what is the access node? Access node, you can just think it is the traditional switches, and it will do the VLAN access. And AP, you know that it is used for wellness terminals, and we use the AP to access to the VXLAN domains. And what is the underlay network and the Fabric? You should know that what is the underlay network? Underlay network, just the underlay network. And we use the OSPF and IGP protocols just to finish the connectivities between the underlay device. And then what is the Fabric? Fabric is a network resource pool, so that is abstract from physical network device on the underlay network. We can creating multi-purpose network. It means all the resources that if you want to configure VXLAN, all right, you need to configure VXLAN. You need to a lot of results. For example, the WAN ID, the BD. All right, we can just to see it. What is the Fabric on the controller? We can check it. You'll find that what is the Fabric. On the Fabric network, you can see we have so many resources. For example, WLAN, bridge domain, WinRS, that is the resource pools. And for the underlays, for example, for underlays, we need to build OSPF. We need to build the interconnection between device, and all the resource is inside the Fabric. And then what is the overlay networks? And I think you should know that overlay networks is a VPN. All right, it is the VPN on the weaponized campus networks, and different services can use the different VPNs. So they are on different virtual networks. And what is VNs? And I think just one thing I can tell you is just from the technical aspect where VN is just VNF, and what can configure on inside the VN. I mean, in the controller, you can configure network resource. It just means DHCP service, third-party radio service, port service, they all the type 5 routers. And external networks, okay, it is also the type 5 routers. And you can use the IP address segment within the gateway address. What it means? It means the VBDF. And at last, it is the access point. It means the VPs. So what is VN? VN is all the things you know about VRF and VXLAN. You can just think it is the abstraction about the VXLAN, just like you can easily use VXLAN. So we can find that we want to use a VN. We need to create the VN. Alright, we need to create the external networks. It means type 5 routers. We need to create a use gateway. It means we believe we need to configure network service resource, and it also type 5 routers. We need to configure the wireless or wireless access. Actually, they are the VP. That is VN. And now let's look at what is the what is the typical requirement about campus network and for Huawei solutions. So we have DHCP service. This service is used to assign IP address for terminals in different departments, and then we need to use the DHCP gateway for them to meet the requirement of the communication between different segment. And we need to create 2 wings, one for OA and one for RDs. It means research and development. And by default, the 2 wings are completely isolated. So we need to do a intra-subnet and inter-subnet communication. So what it means? It means we need to let the 2 wings can learn the routers from each other. So it means we need to do route imported. And the device in both wings can access internal network connected to firewalls. What it means? It means we need to do a type 5 routers, and we need to import these type 5 routers to the 2 wings, to the 2 VRF. So we need to design the RT values, all right? But actually, you don't need to design it. If you the only things you need to do is you need to associate the resource to the wings, and then the controller will design the RT values by themselves. And the terminals in the 2 wings can obtain IP address from DHCP service, and that use the DHCP relay. And I will introduce it in our VXLAN virtualized campus network experiment. So what we need to do, you can find that we need to first add a physical device, and we need to specify a switch to function as a border, and or it should be to function as an edge node. And then we need to the controller will automatically specify the border as an R to optimize the logical network architectures and BGP arrangement mode. And then we can predefine 2 external networks for 2 wings to access the internet. And then we can define network service resource, which is used by terminal to obtain IP address from the service. Okay, all the things we will do in our experiment. And automatic deployment of the fabric and underlay networks based on the discovered physical network topologies and the user-defined fabric. MRC campus will automatically also structure the network, and the controller will deliver underlay network configurations to device. So it means all the underlay configurations will be finished by the controller itself. So we don't need to mention about it. And then management will create different VN, OA and RDs, and specify the IP network segment, VLANs, gateway address, associated external networks, and the network service resource. What it means? It means you need to specify a VBDF and the VP and the IP address of the VBDF, and which type 5 routers can be imported to the wings. That is what you do. And now let's look at the terminal establishment. The BGP European will advertisement the types of 3 routers, alright, and the web tunnels will be established by themselves. And then what is the address openings? After sales deploy a access network, the user is authenticated. After the authentication is succeeded, the authentication point H1 obtains the authorization result of the user and assign the user to the corresponding VLANs. Host A send a DSP request messages after receiving the request message. The gateway H1 relies, notice it is a DSP relay, the request messages to the board node through the WEX tunnels. Why? It's just because the routers to the DHCP service is a type 5 routers is imported by the borders, and by the design of the RT values, H1 can link the routers to the DHCP service. The border node decapsulates the WEX packet and forward the DHCP request message to the service, and then survey assigns the IP address. All right, that is what you learned. After that, let's look at what is the intra-subnet communication. You can know that, for example, the Sales A and Sales B, they are in different edge device, but they are in the same logical networks. So the communication between them will be like this. Okay, we will use the BGP routers to exchange the MAC address and the level 2 VNR values. All right, and then they can communicate with each other. Now let's look at what is the inter-subnet communications. Now we need to use the help of the level 3 gateways. Okay, and you need to type 2 routers for the RB scenarios, and we will carry the level 3 VNRs. Then it is the symmetric RB forwardings. And also access to the external routers. You will find that we will still carry the level 3 VNR values, just because board will generate the routers and send the routers to edge, and it needs to tell the edge which VPN instance the router belongs to. So we use the level 3 VNRs. It's just like the MPLS labels. All right, MPLS labels. Okay, now let's look at the quiz. Look at this part. BGP European Type 2 host IP routers can be used to transmit ARP infos. Host IP routers, we will say that it can include the IP address, MAC address, and level 2 VNRs and level 3 VNRs. But for the ARP information, it lack of level 3 VPNs. So we can find that the Type 2 host IP routers carry more information than ARP information. So it is true. Another question is, which of the following statement about the BGP is false? The first one is, MP-rich antenna is used to carry routers. Yes, it is right. The extended communities attribute is used to carry routers. No, it's not right. And MP-rich antenna is used to carry level 3 and level 3 VPNs. Yes. And the next hop attribute is used to carry routers. We shall know that if we see the MP-rich antennas, we don't have the next hop attributes just because the next hop is carried inside the MP-rich MLRs. And all you can see, next hop is only used for IPv4 prefix. It is used for the BGP 4+, not used for MP-BGP. If it is MP-BGP, we must use, or we can see it must, we will not use the next hop attributes. Now let's do assembly for our lesson. WXLAN use a level 3 root network as the underlay network and use tunnel to build an overlay networks supporting large-scale Telnet networks. WXLAN does not define the control plan to prevent bump traffic flooding. Use other protocols on the control plan to optimize bump traffic forwarding. BGP European defines several new types of BGP European routers. By extending European, those BGP European routers can be used to transmit V-type address, host information, and routing information. And those effectively control flooding of bump traffic. Okay, now it is all the concept about the VXLAN, and I think this part will be more important for you just because it is new part for you, and you need to use a controller to finish all the experiment about VXLAN, and maybe you will find we will examine a lot in this part. So if you don't have you are not similar about VXLANs, maybe I think you need to pay more attention to this part and learn it by yourself. Okay. So actually, I think you don't need to pray for use for a level 3 VPN service just because now we are talking about a VXLAN. It is not the one scenarios. If you mean, for example, in the one scenarios, you can use the level 3 VPN v4 families. It doesn't matter. VPN v4 can support the transporter and the UVPN transporter, but for the VXLAN scenarios, it only support the UVPN. Okay, so that is just for VPN scenarios. For the one scenarios, which VPN v4 and UVPN, both you can use it. But if you're concerned about, for example, if it support SRv v6 or the SMPLS, maybe it have a difference. For example, I remember for the wait a moment. For the spot. Oh, wait a moment. And actually, in our scenarios or in our experiment, I think I need to check if we use a VPN v4 to carry I think we can use it to carry. Wait a moment, I need to check it. You can find that VPN v4 or the UVPN, they can both use to carry the SRv6 or the other traffics. So it doesn't matter which is better, and I think they are the same. Just in some just for one scenarios, and some they think the Europeans can just to have some advantages about the dual active, and but it is not it don't have any relationship in VXLAN scenarios. Regarding firewall, so really for VM is based on also have on systems. Actually, if you know how to meet the requirement about the tenant in DC scenarios, you should know that it is based on the VRF and which systems. In DC, and actually it is the same in our scenarios. But I can tell you our scenario, our campus controller don't support to manage the firewall and automatically So you can think for the DC, they just do like what you said, you based on the VRF and based on which system. And for our scenarios, the controller can't do this, but you can do those by manually configure the firewall. Roma. Yes, Roman, it is impossible for you. Wait a moment. And actually, it's for ESP. For ESP, actually, you can do the ESP transport. Okay, everyone, if you don't have any questions, I think we can finish our training today for a little bit early. And we will do the VXLAN experiment just by command in tomorrow, and in the in a day after tomorrow, we will do the VXLAN experiment by the controller. Okay. Now it is over for today's training. I wish you guys all can have a good day and take care of yourself.